I started recording, sir.
Topic 5. Topic 5. Electric current. IBDP physics. There are two more laws involved in the circuit analysis. There are two more laws involved in the circuit analysis. Two laws of circuit analysis. They are the famous law. They are the famous law called as number 1, Ampere's law. Number 2, Kirchhoff's laws. Please.
Sir, we are going with your hand, sir.
Okay. To my dear friends, just please. Now here, Ampere's law means Ampere's law means that is meant for parallel conductors. Whenever the current is carried in the same direction, whenever the current is carried, say conductor 1, conductor 2. Conductor 1 is carrying current I1, conductor 2 is carrying current I2. Then the force experienced is there is a like currents in the same direction. Like currents, force experienced is attraction. These two conductors attract towards one another. So that way, that means that this is a type of attraction. They will attract. How? The force experience is such that this F is equal to BIL. On conductor 1, it is I1, L1. Length is the same. Length is same. L1 is equal to L2. So, suppose I1 is equal to I2. So, F1 is B, I1, L1. But B, who is giving B? Who is giving B?
Sir, the conductor.
I1. I2 is giving the B. I2 is giving the magnetic field. Because any conductor carrying current produces magnetic field. So the B is of second conductor. Okay. Now what is magnetic field produced by current carrying conductor? There is a formula that B in general is given by mu0 I upon 2R. I'll tell you, mu0 is a permeability constant, 4.8 I is a current carried by the conductor, and R is how far this conductor is away from this. So this R either this way or R this way. So if it is B2, this implies B2 means mu0 I2 upon 2R. If it is B1, mu0 I1 upon
1R.
So let us apply this formula. So what is F1? F1 is B2. Apply this formula. mu0 I2 upon 2R into I1 into L. Okay. What is F2? F2 is Bill. Bill means B1 because the force of this conductor will be Bill, where B is supplied by this conductor B1 and I is current carried by this conductor I2. L2 is same as L. But what is B1? We have already written. Let us substitute. B1 is mu0 I1 upon 2R into I2L. What do you control? Look at this F2 and F1 formula. F2 and F1, are they same? Are they same?
No,
F1
sir.
and F2.
No, sir.
They are same. V0. 2R. I1, I2. L. So force experienced on conductor 1 and conductor 2 is the same. Per unit length means F upon L is the same. So they are with equal and opposite forces, they are attracted. I am saying that F1 will be in this direction and F2 will be in this direction. How? You have to apply which rule? Fleming's motion of a conductor. Fleming's left hand rule or right hand rule? Fleming's left hand rule. So apply Fleming's LH rule. Fleming's LH rule. Do you want me to show Fleming's left hand rule?
No, sir, we know.
Yes?
We know, sir.
Now, Kirchhoff's law for current, what does it mean? In a circuit, you may come across many junctions. You may come across I1 is coming here, I2 is going out, I3 is going out, I4 is coming in, I5 is coming in, I6 is going out. So, what is this? Current law says that summation of all the current at a junction is equal to 0. Summation means, let us take approaching is positive. Approaching, current coming towards a junction is positive. You will take your side. Current leaving is negative. You decide. Suppose current approaching. Who are approaching? I1 positive. I2 negative. I3 negative. I4 positive. I5 positive. I6 negative. So this is what Kirchhoff scientist he said that in order to analyze, so far you are not analyzing a complicated circuit. What we are analyzing is very simple. There are some circuits where this is having one supply, this is having another supply. So many complicated circuits are there. Then with respect to this junction, current is leaving. You decide in advance. Leaving means negative, approaching is positive. So this forms one equation. Maybe one of the cannot be simultaneous equation. Simultaneous equation has only two variables. Here there are 6 variables. But yes. So but this equation will be useful in analysis. Along with voltage equation. What is Kirchhoff's voltage equation? Kirchhoff's voltage equation is, suppose you have a circuit like this. There are two supplies.
At the point it all will be equal.
Yes. There are two supplies. This is R1 and another supply. So there are two loops. There are two loops. Loop 1. This is loop 1. This is loop 2. I can consider the entire thing as loop 3. That was I can say. Now in this case, how to apply voltage law? What is voltage law? Summation of the battery voltages is always equal to summation of the product of current and resistance. How to apply? Loop 1. You take this loop. So this is the current I. Now in advance you decide, I will take anti-clockwise. In advance you will take this anti-clockwise is positive and clockwise is negative. Here what we have taken? Approaching is positive. Approach is positive. Receding is
Negative.
negative. You can reverse it. But apply the same condition for all the circuit. So let me take loop 1. What is how many batteries are there? Only this loop 1. Only one battery. So B. We call this as B1. This as B2. So here B1. But only one battery is there. Then what is current is moving in this direction? Let us say I1 is a current here and this delivers a current of I2. So I1 passing through R1 is equal to I1 R1. Had I put one more resistor, suppose, which is R2, then I will be writing plus I2 R2. That is the meaning of sum of the product of current and resistance on one side is equal to sum of the battery voltages. Here there is only one battery. Let me take loop 3. Loop 3 is the entire one. Loop 2 is this one, lower off. Loop 1 is upper off. Loop 3 is total loop. Means the big loop. When I take total loop, then you can form three equations for loop 1, loop 2, loop 3. So here I have taken this as positive. There are two batteries. So this is V1, but this battery is in the reverse way. So this is sending current in the reverse way. So I will be writing V1 minus V2 is equal to summation, or not summation, I am going to write. Now this will not come here. This will not come into the picture. This loop I am taking. When I take I1, what is this value I have got? R3. I1 R3, then but when I come here, here there is I2 opposing current. So I must write I1 minus I2 into R3. And then when I come here, it is I1 is here, but this current will not go here, it will be coming down here. So it is I1 R2. This I1 R2 is same as this. This is I1 R2. It should be I1 R2. So we have to apply this equation.
When it be I1 R2.
Loop 1, only one current, I1 R1, I1 R2. In loop 3, I1, but when it comes here, opposing next is. So I1 minus I2 R3, and then when it comes here, the current is only I1. So like this, you write the equations, and you will get many formulae, and then solve combining all this. So Kirchhoff has discovered this equations of current and voltage. It is what is Kirchhoff's law. Ampere mentioned that suppose he says like currents are attracting. Can you guess what would have been their unlike currents? If it is currents are unlike, currents are what will they? They will be repellent. Very good. So unlike currents will repel. If the currents are unlike, they will repel. You will have the same formula. You can explain the above Fleming's left hand rule. If they repel, then the equation of repulsion will be, the figure for repulsion will be like this, as if the circles are moving away, like this. They move away. The magnetic fields move away from one another. So thank you very much. Stop it.